Bridges, wonders of engineering. Have you ever walked or driven across a bridge? It's pretty amazing, right? Bridges are like giant, strong pathways that help us cross over water, valleys, or even other roads. But how do these massive structures stay up without sinking? That's what we're going to explore today, the science behind why bridges don't sink. Bridges are engineering marvels. They're designed and built by clever people called engineers who use science and math to make sure the bridges are strong and safe. It's like building with giant Legos, but instead of plastic, we use strong materials like steel and concrete. The Golden Gate Bridge is a great example. It's a huge bridge, but it doesn't sink because of clever engineering. Engineers figured out how to balance the weight of the bridge with the forces that push up from the water and ground below. Let's dive in and learn more about the secrets that keep bridges standing tall. And don't forget to subscribe to my YouTube channel, the Why Channel, for more fascinating insights. Floating bridges. It's all about balance. One of the most important reasons bridges don't sink is something called buoyancy. You know how a boat floats on water? That's buoyancy in action. Objects float when they push aside enough water to support their own weight. It's like a seesaw. If the weight is balanced, the seesaw stays level. Bridges, especially those that go over water, use buoyancy to their advantage. They are designed in a way that they displace enough water to counteract their own weight. They're like giant, carefully balanced boats. But it's not just about buoyancy. Bridges use other cool engineering tricks to stay afloat, and we'll learn about those next. Sharing the load. How bridges handle weight. Imagine carrying a heavy backpack. It's tough, right? Now imagine sharing that weight with a friend. Much easier. Bridges do the same thing. They share the load. When a car, truck, or even a train goes over a bridge, it puts weight on the bridge, but the bridge doesn't try to hold all that weight in one spot. Instead, it spreads the weight out. Think of it like this. If you step on a trampoline, the whole thing bends a little, right? That's because the trampoline spreads your weight out. Bridges do something similar. They distribute the weight across their entire structure, from the road surface down to the foundations. This way, no single part of the bridge has to hold up all the weight by itself. Sharing is caring, especially for bridges. Strong foundations, anchoring bridges in place. We know bridges share the load, but where does all that weight go eventually? Into the ground, of course. But bridges don't just sit on top of the ground, they have strong foundations that go deep down. These foundations are like the roots of a tree. They anchor the bridge in place and transfer the weight safely into the earth. Building strong foundations is super important, especially in places where the ground might be soft or shaky. Engineers use different methods to create strong foundations. Sometimes they drive giant concrete pillars called piles deep into the ground. Other times they dig down to solid rock and build the foundation directly on top. No matter what method they use, the goal is the same, to make sure the bridge has a solid base that can handle all the weight and pressure. It's like building a house on a strong foundation. You need a good base for everything else to stand on. Section 5. Pillars of Strength, supporting the bridge from below. Now that we know about foundations, let's talk about the parts of the bridge that we see above ground. One of the most important parts are the pillars, those tall, strong supports that hold up the bridge deck, the part we drive or walk on. Pillars act like really strong legs for the bridge. They're strategically placed along the length of the bridge to provide support at regular intervals. The weight from the bridge deck and everything on it gets transferred down to these pillars. The size and shape of the pillars depend on the size and design of the bridge. Some bridges have slender, elegant pillars, while others have massive, imposing ones. But no matter their appearance, they all serve the same purpose, to hold the bridge up. These pillars are incredibly strong. They're designed to withstand not only the weight of the bridge itself, but also the weight of all the traffic, wind, and even earthquakes. They're like the unsung heroes of the bridge world, quietly and reliably doing their job. Section 6. Arching over distributing weight with curves. Have you ever noticed that some bridges have beautiful arches in their design? These arches aren't just there to look pretty, they actually play a crucial role in supporting the bridge. Arches are incredibly strong shapes because they distribute weight outwards along the curve. When weight is placed on an arch, it pushes down and outwards, transferring the force to the supports at either end. Think of it like squeezing an empty aluminum can inwards. It's tough, right? But if you turn the can on its side and press down, it's much easier to crush because you're not working against the arch shape. Arch bridges have been used for centuries, and some of the oldest bridges still standing today are arch bridges. They're a testament to the power of this simple, yet effective design principle. Section 7. Suspension bridges, hanging by a thread. Not really. Now let's talk about suspension bridges, those impressive structures that seem to hang in midair. Think of the Golden Gate Bridge or the Brooklyn Bridge. These bridges use a fascinating combination of tension and compression to stay up. Suspension bridges have tall towers that support massive cables. These cables are anchored at each end of the bridge and run along the entire length. From these main cables hang smaller vertical cables called suspenders, and these suspenders hold up the bridge deck. It's like holding a piece of string with a weight attached to the middle. The string is pulled taut by the weight, and that tension helps to keep the weight from falling. In a suspension bridge, the main cables are like the string, and the bridge deck is like the weight. The towers of a suspension bridge are under compression because they're being pulled inwards by the cables. The cables, on the other hand, are under tension. This balance of forces is what allows suspension bridges to span such incredible distances. Section 8. Material wonders. What bridges are made of. We've talked a lot about how bridges are designed, but what about the materials that make them so strong? Bridges are built from a variety of materials, each chosen for its unique properties. One of the most common bridge building materials is steel. Steel is incredibly strong and can withstand a lot of tension and compression. It's also relatively lightweight compared to other strong materials. Another popular material is concrete. Concrete is very strong under compression, which makes it great for foundations and pillars. It's also relatively inexpensive and easy to work with. Sometimes engineers combine materials to take advantage of their different strengths. For example, they might use steel cables for tension and concrete for compression in a suspension bridge. It's all about finding the right material for the right job. In recent years, engineers have also started using new, innovative materials like fiber-reinforced polymers, which are lightweight and incredibly strong. As technology advances, we can expect to see even more amazing bridge-building materials in the future. Section 9. Famous bridges engineering marvels around the world. We've learned a lot about the science behind why bridges don't sink, but now let's look at some real-world examples of these engineering marvels. The Golden Gate Bridge in San Francisco, California is a world-famous suspension bridge known for its iconic red-orange color. It spans a distance of over a mile and was once the longest suspension bridge in the world. Another famous bridge is the Sydney Harbour Bridge in Sydney, Australia. This bridge is an arch bridge and is nicknamed the coat hanger because of its distinctive shape. It's a beloved landmark and a symbol of Australia's engineering prowess. And we can't forget about the Tower Bridge in London, England. This bridge is a combined bascule and suspension bridge, meaning that the central section can be raised to allow ships to pass underneath. It's a true feat of Victorian engineering. These are just a few examples of the many incredible bridges around the world. Each bridge is a testament to the ingenuity and creativity of engineers who use science and math to design and build structures that connect us all. So, the next time you cross a bridge, take a moment to appreciate the amazing engineering that keeps you safe and sound above ground or water. It's a fascinating combination of science, math, and a whole lot of creativity.